Hello, this is Sarah Woodward. This is my instructional notebook assignment for EDT 6005. Today we're going to be looking at rates of change in tangent line equations. So to warm up, we have a pretest on our reading that we did last night out of the textbook. So here are our words, right? Some vocabulary words. And let me make it so they're all on the screen. We just want to match these up. We have tangent line, average rate of change, different quotient, instantaneous rate, secant line, normal line, and slope of the curve. That's what we got. So we're going to look at this and we're going to match them up. So a line that connects 2 points on a graph, that's called a secant line. Secant, we did this as a warm-up in class if you missed it. Limit as h goes to 0 of f of x minus f of h divided by h. That is the slope of the curve. We're going to be using that formula today in our second example. The amount of change divided by the amount of time it takes. That's how you find the average rate of change. That's our first example. Perpendicular to a tangent line is called a normal line. Instantaneous speed, also known as instantaneous rate of change. Our difference quotient, that's what we're going to use with our average rate of change and our slope of the secant line. A line that touches only 1 point of f of x and lays along that side, that's called a tangent line equation. So in class, we had each group came up, one person from each group came up and matched them, and then we checked to see if we got it right. And hopefully we did. Yay, we did it. All right, so let's take a look. We have a couple examples here. All right, so we have example, find the average rate of change. Okay, so let me find the average rate of change of a quantity over a period of time, okay, is the amount of change divided by the time it takes. This is where we have our f of b minus f of a over b take away a. And here we have two things. We have a b, suspect. All right, we have b, and we have an a, right? We have a b and we have an a. And the b, right, is our last number, and our a is our first number that's given in our interval. So here we have the equation 2x squared minus 3x, and that's what we're going to be doing. So our first step is to figure out what's f of b. So we plug in f of 4, so 4 goes in 2 times. There's 2 x's, I did that on purpose. F of 4, and we just use basic arithmetic to solve it out. So 4 squared is 16. 2 times 16 might take away 12. 31 take away 21 is 20. So that is our f of b. So when we think about our difference quotient over here, right? When we think about that, right? And I'm gonna get rid of some of this stuff. When we think about that, that tells us that we know 2 of our quantities. That tells us we know the quantity f of b, we know this is going to be, we're going to put in 20, and b is going to be our 4, okay? And we'll do this we'll make it look pretty in a second. So then we have our f of minus 1, or a, we plug that in 2 times, and we get subtract 10. So now we can take our subtract 10, and we can take our 4, and we can also plug that in. So let's do purple, I love purple, right? So we would do minus 10, okay, and then we would do minus 1 down here. So when we go to set up our difference quotient, I'll just type it in, we have 20, take away a negative 10, right? And this is where we have to really pay attention to our negative symbols, because that's usually the number one place where difficulties come up, is we forget a negative. So we have 4 take away a minus 1 on the bottom, right? So we can see that here, and that's why I kind of like to cross this out and put that here, because you see 20 take away minus 10, or 20 plus 10, we'll do that in a second, 4 take away minus 1. So this whole party here turns into 20 on the top, 20 plus 10, 20 plus 10, and then on the bottom we end up with a 4 plus 1. So our 2 fractions we're dividing, okay, when we go to set up our fractions, is 30 on top, and then on the bottom, that's some bottom, we end up with 5. So 30 over, come on, let's go, 5. So we can divide 30, divide by 5, and we can get our answer. We can say that is equal to 6, and that's our answer. Okay? So let's just kind of review the steps we took to get here. So our first step was we found f of 4. So we plugged 4 into our original equation 2 places. And we got 20. Then we took -1 and plugged it in 2 places and got -10. So we have our b, our 20, and our -10, all divided by 4, subtract -1. We plugged that into our equation. We remembered our negatives. That's the biggest place there's mistakes, is with the negatives. And then we simplified that to get 6. And that would be our average rate of change on that interval of the function. All right, next up, use the slope of the line, right, slope of the line at the curve to find the slope of the tangent line. So that's what we're going to do now. And what we want to do, right, we're going to use this equation I have up here. And there's a couple different things we have to figure out. First, slope of the point at A. So we have the slope of this line, x squared plus 3x. Notice there's 2 different x's, 2 places you're going to have to plug this value in. I did that on purpose because practice. So first thing we do is f of 1. This is pretty simple. This is the most basic part. So f of 1 equals this. And then 1 plus 3 is equal to 4. So we get 4. So that tells us in our equation right here, our limit, we're going to have a 4. Subtract 4 right here. We'll make it pretty in a second. And then we have to do the same thing with 1 plus h. Now here we have to square 1 plus h. That's the one way we're going to distribute this. And then we're going to have to distribute the 3. So 1 plus h times 1 plus h plus 3 times 1, 3 times h. So let's do this in parts. This is 1 plus h times 1 plus h. You FOIL it. 1 is 4, or 1 times 1 is 1. 1 times h is h times 1 is h, and h times h is h squared, plus 3 plus h. And you can combine your like terms. You have 1 and 3, that makes 4, and you have 3 h's, and then you have an h squared. Okay, so let's do it. Let's make it happen. So that tells us that this right here, this is what's going to turn up. We'll do it in blue, and we'll fit it all in right here. So we're going to have a 4, right, a 4, and then plus 3h, and we'll make this pretty in just a second. 3h. H plus h squared. And don't forget, then we're going to do that. And we go to do it, we'll do this minus 4. All the limit as h goes to 0, all of that. So let's take a second and let's do it, right? So let's take all this. And this was all really good work, but I don't want it to take up too much space in my screen. So let's kind of take it like this with it, yeah. Don't take up too much of my life here. All right, so that's what we have. That's our equation. That's all of our work. So let's set this up. So we have the limit as h goes to 0, and I'm going to keep typing that of our difference quotient here. So we have, so on top we have 4 plus 3h plus h squared, right? That's our one term. And then our second term would have been, let's see, it would have been 4. Okay, and we're going to subtract that. So I'm just going to write the subtraction for a dramatic effect. Subtract. And then all that divided by h. Okay? That's what we get. So the reason why I think this is neat and it's cool is that you should always get stuff that cancels out or adds to 0. So when we go to do this to simplify this, right? So let's just, I'm going to rewrite it. So when we go to simplify this, we notice that the 4 that we have here and the 4 here, right? Those two 4s, they can go away. They're gone. So we're not subtracting that 4. We're not subtracting the 4 anymore. Basically what we did is we did 4 minus 4, that goes away. You guys are good at this because we've been practicing limits for a very long time. So this is like the easy stuff. Now we want to get rid of our h's. This is where we make our heart, right? So this is where we make our heart. So I say h divided by h, right, is going to be one quantity, and then h squared over h is going to be another quantity. So we're going to do the same thing again. So we're going to say this is equal, okay, this is equal to the limit as h approaches 0, and then of what? 3 plus h. And now you guys are so good at this, you know we can just use substitution to get our answer. And so we would just use our substitution and we would do it. So we would say, well, that's going to be equal, right, we're going to use substitution, 3 plus h, so instead of putting h, we're going to put 0, equals 3 plus 0, which is just 3. So that tells us that our answer here for the slope of our line is going to be 3. That's our answer. Okay? That's what it is. So here we go. Use so let's just kind of review our steps. What do we do here? So first step, we have our difference, our slope at a point where we use f of a plus h and f of a, and we have to identify what the point is, and that'll usually be given to you. Sometimes you might have to read it from a graph. Then we'll do f of 1 and 1 squared plus 3 times 1, 4. So that goes in our last half, and then f of 1 plus h. I like to do that first because it's simpler. I feel like confident when I get it done. And then f of 1 plus h, so you multiply this out, you distribute all this, and you end up with this. And usually you should get, then when you go to plug them in, 1 in the front, 1 in the back, there are things that should cancel. The whole number should cancel, or the number should cancel, and then the h's should be able to divide out. And you can make a heart. Sometimes there's more than 2. And then you use substitution. You guys are very good at that. And we got our answer is 3. All right, here we go. We have 2 questions here. Okay, find the average rate of change of f of x on the interval from -3 to 3, and find the slope of this at the point x equal to -1. So I gave the class some time to think on this, and we got the answer of 0, and we got the answer of 36. So you could try those on your own and see if you get the right thing. Thank you. If you have any questions, please let me know. Stop by my room J119. Thank you.